Color in coordinate compounds. The CFT explains the formation of the color in coordinate compounds. How? Let me give an example. Like in the case of hexa aqua titanium 3 ion. See, in this case we know the d orbitals are like this in the ground state. They are degenerated. The energy gets increased, but they still remains degenerated in the excited state. They are like this. Then they splits up into two parts, like we know it's T2G and EG, and the energy difference between them is decided by the crystal field splitting energy in octahedral complexes. Now what happens is the titanium in this case is in 3D1 configuration. It's in +3 state, so it's having 3D1 4s0 configuration. So it is having only one electron here, which will be occupying the T2G orbitals. Now what happens is, see the energy difference of the energy required for the electron to jump from this T2G to EG and then to come back, this is called DD transition, is so less that this energy required for this kind of a transition is even available in the visible light even at a very, very low temperature. So that is why even the normal visible light, which is having VIB-Gyor, is sufficient enough to provide the necessary energy required for the transition of this electron, which is within the orbitals of the same suborbit. See, that is all. If we want to see the color of the sodium, we have to heat it, because that is how the electrons of its sodium are to be excited from one energy level to the another energy level. Energy required is much higher. It only shows color when it is heated. But in this case, there is no heating is required. Why? Because the transition of the electrons is taking place within the orbitals of the same suborbit, which have gone into the splitting due to the influence of the ligand. The energy required for this is so small that is easily available in the visible region. One of the colors is absorbed for this transitions, or more than one even, most of the cases one, and rest of the colors are reflected back. Now, which color is the compound will be actually acquiring? The color acquired by the compound will be complementary color to the color absorbed. Like in this case, yellow region is absorbed. So this reflected light in fact is having violet, indigo, blue, green, dash, orange, red. It's not having yellow because yellow has been absorbed. So which color will appear to us? See, we know the complementary colors. What? Violet, blue, green, yellow, orange, red. These are the complementary colors. Yeah, see, if violet is absorbed, it will appear yellow. If yellow is absorbed, the compound will appear yellow. If blue, orange, orange, blue, red, green, green, red. These are the complementary colors. So since yellow was absorbed, the compound will appear to us as violet. So what this example tells us that the necessary conditions for a compound or coordination entity to show the color is the presence of unpaired electrons, which must undergo DD transition. Otherwise, even if you are having an unpaired electrons and no DD transition is possible, no splitting has taken place, there will be no color. Like, I can give you an example. Like, let's take example of the very common copper sulfate crystals. We know copper sulfate 5H2O is a blue colored crystalline salt, but when heated, we know it gets what? It changes to anhydrous salt, and it leaves out 5 water molecules. Now, see, this anhydrous copper sulfate is white. How it has become white? Here also it is in 3D9 configuration, so it is having one unpaired electron. Here also it is in 3D9 configuration with +2 state, and again having a one unpaired electron. Then why, in spite of having unpaired electron, copper sulfate anhydrous is not showing any color? The reason is because this complex actually exists in this form, like this, sulfate.H2O. So this water causes the splitting of the d orbitals. In this case, when it is hydrated, and due to those splitting, the DD transition takes place due to the presence of unpaired electron. If there is no water, no ligand, no splitting, no DD transition, so in spite of having one unpaired electron, it is white. That is what is the basic of the color of in the coordination compounds.